Hello everyone and welcome to PC Retro Tech. So in this week's video I want to show you a CGA demo effect that I've been working on for actually a few months now, and it involves drawing really fast ellipses on the screen. So one of the reasons I really like building old computers is not so much to play games, that's also fun, but to actually program them and see if you can push the limits of the machines and see just how fast they can be made to run, even with such limited hardware. So that's what I'm doing this week. I've written some really fast ellipse code in assembly language. There's in fact over 1400 lines of code just to draw ellipses, and so I want to show you just how quickly they go. So before I show you the code that I wrote, let me just show you how things were back in the day if you were using the ball and graphics library. So that's the library that would have come with Turbo C or any of the other ball and turbo language products. This is what it looks like. So it's starting out here, it's just drawing larger ellipses, and they're getting smaller as it goes across to the right of the screen, and they're also getting narrower. So I won't let it run all the way through because it runs through 10 times and each one is 18 seconds, so in total it's about 3 minutes worth. So the new code will run a lot faster than that. I'll show you that in a second, but before I do, I just want to mention that one of the tricks that I'm using in the new code is due to a guy called Reenigne. So I got to talking to him on the Vogons forum, and he came up with some really brilliant ideas, and one of those turned out to be really useful in getting fast ellipse code. So I've incorporated that in my assembly language. So let me show you what the result is. So let me run that exact same demo through, but now using my ellipse code, and we'll see how long it takes. As you can see, it's really a lot faster. In fact, this will complete in just under 12 seconds. So that makes it about 15 times faster than the ball and graphics library. So this is all very pretty and so on, but let's see if we can come up with a nice demo effect that makes use of ellipses. So I'm going to put together a little effect. I'm going to gradually improve it until we get to the final result. So the first thing I'm going to do is I'm just going to draw ellipses across the middle of the screen, but I'm going to change their size in a kind of sine wave pattern. So here's what I came up with, and you can see that the ellipses are just getting bigger in a kind of sine shape, and they're also changing width as well as they go across the screen. I wasn't originally going to have them flash to black, but I think it actually looks pretty cool, so I'm just going to leave it like that. But let's move the ellipses down to the bottom of the screen and make them arch up in a kind of bow across the bottom. So that seems to be working, and I think it looks pretty cool, but let's put this same pattern all the way around the whole screen. So this is how it looks now that I've made those changes. So it really wasn't looking great with the black every fourth color. So instead of what I've done here is just make it black out the ellipses 180 degrees out of phase with the ones that are being drawn. So now it looks like there's a little worm that's just sort of bouncing around the screen. So I'm pretty happy with this. This is kind of the effect that I was looking for. But let's try and snazzy it up a little bit. And so what I'm going to do now is put a little chaser in the middle of the screen. We've got a little bit of real estate left there and still a bit of horsepower left in the CPU. So let's draw some vertical lines that sort of chase back and forth across the middle of the screen. So this is what it looks like, and as you can see I made the little chaser in the middle sort of match the shape of the elliptic worm that's going around the outside. I think this looks pretty good, but I think I'd like to have a little bit more colour now. So there it is, folks. I've added a few little stars that blink in and out of existence, and of course I'm cycling through all the 16 colours that the background can be set to. Normally it's black in most games, but you can actually use 16 colours for the background in CGA mode. Now of course there's only so much you can do with lines and ellipses and circles, of course. There's a few other things I would have liked to have added here. Certainly would have liked to have added some music to this. One of the difficulties with doing that is the ellipse code actually turns off the interrupts, so there's a limited possibilities for how to get music running here, but you could actually do it. The other thing I could have done, of course, is have the screen move up and down just to give it a bit more motion. But this is basically what you can do with CGA in terms of computing on the fly for a demo effect. Now, of course, a real demo effect would do a lot more pre-computation. Of course, I'm only using a small number of different size ellipses here, so I should, of course, pre-compute all of those and just essentially, put them onto the screen from an array or something like that. That would go a lot faster. And there are various other tricks that demo coders use, but I wanted to see how far I could push it actually computing things in real time rather than just pre-computing. So that's everything for this week, folks. Thanks very much for watching, and I hope you enjoyed this. If you did, don't forget to like and subscribe, and we'll see you in a later video. Bye! So there's just a little addendum here. I decided to set the background color just to blue. It was actually playing a lot of havoc with the camera there. And I've also turned turbo on, which means that the whole thing goes a lot faster. So this is at 8 megahertz. And I think it looks a little bit more impressive when you have it at that speed. It's unfortunate that the CGA adapter itself is so slow in these things, and it's also really a shame that you can't get 16 colors everywhere on the screen with CGA. But anyway, that's it. I just wanted to show how it looks going at 8 megahertz.